Good day, everybody. Today. We're talking about cones. We're taking examples and exercises on cylinders. Now let's go to cones. It's the 25th of June, 2020. Now let's see cones. Okay, now this is what a cone looks like. That's a cone. This is called this vertical represents its height, while this represents its base radius. This is its vertical height, and this is its slant height. Now, let's take a few formulae. The curved surface area of a cone. Curved surface area is given by the formula. The curved surface area of a cone is given by the formula pi RL, where R is the base radius of a cone, L is its slant height, and pi is always given as 22/7, and also the total surface area. Total surface area of the cone is given by the base area, which is pi r squared, because the base is a circle, so its area is pi r squared, plus the curved surface area, which is pi r L. And you can write this as pi r into r plus L. Now let's take a very simple example. That's our first example. Example 1. A cone has a base radius of 5 centimeters and a height of 12 centimeters. Calculate A. Calculate A, its slant height. B, its total surface area. Leave the answers in terms of pi. That means we are just leaving pi as it is. We're not using any value in terms of pi if pi is involved. Leave your answers in terms of pi if pi is involved. So wherever pi is involved, we're leaving it as pi. Now that's it, very simply. Let's solve that. Solution. A cone has a base radius of 5 centimeters and a height of 12 centimeters. Calculate A, its slant height, and B, its total surface area. That's a piece of cake. Let's take that. This is a sketch of a cone. This is its height, while this is its base radius. Base radius is 5 centimeters and height is 12 centimeters. And we are to find its slant height. Let me call that L. Now you can see that there's a right angle triangle in there, which is this. Let me bring out that right angle triangle. That's the height. This is the slant height, and this is the base radius of the cone. Now the height is 12 centimeters. The slant height of the cone is unknown, and its base radius of the cone is 5 centimeters. So we can find L from this right angle triangle, which is what I'm going to do. Using Pythagoras Theorem, we know that the square of the hypotenuse, which is L here, is the same as the sum of the squares of the lengths of the two other sides. So that means L squared is the same as 12 squared plus 5 squared, and that's 144 plus 25, which is 169. If L squared is 169, that means L equals square root of 169, which is 13 centimeters. Therefore, the slant height of the cone is 13 centimeters. The slant height of the cone is 13 centimeters. And that's it, very simply. Now we go to question B, which says find its total surface area. Mind you, we are using pi, leaving pi as pi wherever pi is involved. And that's question B. Find its total surface area. The total surface area of a cone is given by the formula total surface area equals pi r squared plus pi r L, and this is the same as pi r into r plus L. And in this case, pi is still pi. The base radius of the cone is 5 into bracket 5 plus the slant height, which we just found to be 13 centimeters, and that means pi times 5 times 18, and that's 90 pi centimeters squared. So that's it simply. Let's take a second example. Example 2. A sector of a circle of radius 10 centimeters and angle of radius 10 centimeters and angle 216 degrees is bent to form a cone. Find the following. A, the radius A, the radius of the base of a cone, the radius of the base of the cone B, the curved surface area of the open cone, the curved surface area of the cone, the curved surface area of the cone. Now let's see, that's another very simple one. We just need to know what the relationship between a cone formed from a sector is. Now let's go to the solution. Now that's A. Now let me have this as the cone, as a sector. If this is a sector, it's a major sector because its angle is a large angle. I see that. Now this is the angle of the sector, 216 degrees, and let's make this the cone that is formed from it. This is a cone into which the sector is bent. Now, so this is one thing we have to always remember. Let me call the radius of a sector R1 and the cone as a height and also a base radius. I'm calling the base radius of the cone R2. Of course, its slant height. Okay, its slant height is L. Now, whenever a cone is formed from a sector, whenever a sector is folded into a cone, the circumference of the base of the cone, the circumference of this circular base of the cone is going to be the same as the length of the arc of the sector, which is this major arc. Circumference of base of cone, and that's given by 2 pi r, because that base is a circle, is the same as the length of the arc of a sector that is folded into the cone, and that's given by theta over 360 times 2 pi r. So that fact is very, very important. You have to always remember that whenever a sector is folded into a cone, the circumference of the base of the cone is the same as the length of the arc of the sector. If you try that yourself, you'll see it is quite true. By cutting out a sector, cutting a sector out of a circle and folding it to form a cone. Now, and one other thing, you notice that the radius of the sector, which is R1 in this case, is also going to be the same as the slant height of the cone. So those are the two facts you must always remember. Whenever a sector is folded into a cone, the circumference of the base of the cone is the same as the length of the arc of a sector, and the radius of a sector is the same as the slant height of the cone. Now let's go to the solution. Here we are asked to find the radius of the base of the cone. Okay, so circumference of cone, circumference of base of cone equals length of arc of sector. They are the same. And we know what the circumference of the base of a cone is. That means 2 pi r. I decided to call it r2 so we don't get confused. Of course, this will be 2 pi r2. That means 2 pi r2 equals 2 pi r2 equals length of arc of sector, theta over 360 times 360 degrees times 2 pi r1. R1 is the radius of the sector, and that simply means 2 times, in this here we are taking pi to be let's check what's the value of pi. 2 pi. Okay, we don't even need to use any value for pi because it's common to both sides of the equation. So first of all, I want to divide both sides by 2 pi. Dividing the right hand side by 2 pi is the same as, or let me write that, dividing both sides by 2 pi. That means 2 pi r2 divided by 2 pi is equal to theta over 360 degrees times 2 pi r1. Dividing this by 2 pi means multiplying it by 1 over 2 pi. It's the same. So 2 pi cancels 2 pi. 2 pi cancels 2 pi here. And then we have r2, which is the base radius of the cone, equals theta over 360 times r1, which is the radius of the sector. And that's 216 degrees divided by 360 times radius of the sector, which is, well, let's check what the radius of the sector. 10 centimeters. 10 centimeters times 10. And then, of course, 0 cancels 0. And here we have 36 in 216 is 6. And that means r equals 6 centimeters. And we can say, therefore, the base radius of a cone the base radius of a cone is 6 centimeters. Now question B, which says the curved surface area of the cone. To find the curved surface area of the cone, we need its slant height. We need its slant height, L. So I now know radius. Do I know the height of the cone? Okay, let's see. Oh, of course I know that the slant height L of the cone is the same as the radius of the sector. So question B, slant height of cone equals radius of sector. So that means L. We can now say, therefore, curved surface area curved surface area of cone equals pi r L, and that's the same as pi times r, the radius of the cone is, base radius of the cone is 5, times L, which is the same as the radius of a sector, 10 centimeters. And that base radius of the cone rather is 6. We just found that 6 centimeters. And that's 60 pi centimeters squared. 60 pi centimeters squared. And that's it very, very, very simply. That's it very, very, very simply. Now to the very, very last example, example 3. Example 3. Calculate. Okay, I think I'll make this an exercise instead. Exercise. Calculate the total surface area. The total surface area of a solid cone of vertical height 24 centimeters and base diameter and base diameter 14 centimeters. And here they want us to use the value 22/7 for pi. So pi is 22/7. And that's it very simply. I'm sure you'll be able to answer that question. Alright, that's where we slam the brakes. See you in the next class, and please submit your work. Thank you very much, and bye-bye.